Okay, so section 3 is all about the multiplication properties of exponents, and many of these we have seen before in 7th grade. So a couple of things you need to know. You're going to be told to simplify your expressions, and that's going to be the only direction you're given. Simplified exponential expressions have these properties. There are no negative exponents in your answers. There are no repeated bases in your answers, meaning you won't see like x to the 5th and x to the 7th in your answer. There will be no power to a power, no product to a power, no quotient to a power. You'll see what I mean about those as we go. And numerical coefficients are simplified, meaning if you have something like 3 to the 4th power, you're going to change 3 to the 4th to 81 in your final answer. Numbers to exponents you must work through. So if you don't know exactly what you have to do to simplify, here's a list of the properties. So let's talk about our rules. First up is the multiplication rule, and this is actually, as I look at it, incorrect. So let me try to squeeze my cursor in here and make this correct. So bear with me for a second. I gotta plug my keyboard in, and there we go. And I'm gonna back out of this for 1 second so that it saves it. It saved it. There we go. Okay. So the multiplication rule says if I've got the two copies of the same base, a and a, with exponents, I can write that as a single version of the base to the sum of the exponents. Meaning, if I see the same base twice and they're multiplied, I can add the exponents together. Simplify and leave answers in exponential form. So if you see the added directive, leave answers in exponential form, that's saying you don't have to work out something like 2 to the 17th power, because that would be a very large number. If you just see simplify, you must work them out. If it says simplify and leave in exponential form, you don't have to work it out. So 2 to the 5th times 2 to the 6th. The base here is 2. The exponents are 5 and 6. So I can combine these to 2 to a single power by adding 5 and 6. So 5 plus 6 is 11. The simplified version is 2 to the 11th power. In the next example, I have multiple terms. I've got 4s and 3s. So I do need to tackle them separately. So let's do them in order. 3's first, because 3 is smaller than 4. 3 to the negative 2nd and 3 to the 6th. Okay. Part of you may be saying, hey, that negative 2, that's a problem. We've got to take care of that. Yes and no. We will take care of it, but I want to combine my bases first. If I don't have a negative exponent after I do that, I'm going to save myself some effort. So the two things that have base of 3 have exponents of negative 2 and 6. I add the exponents together. Negative 2 plus 6 is positive 4. And that's just fine. I don't have to do anything to that. So don't worry about the negative exponents until they show up in your simplified form. Looking at my 4's now, I have a 4 to the 2nd power and a 4 to the 5th power. When I put those together, 2 plus 5 is 7. And it is multiplication between these. There's no addition, no subtraction going on. This is multiplication. So 3 to the 4th times 4 to the 7th. In the next example, I've got an a to the 4th, a b to the 5th, and an a squared. I see two things that have a base of a, so they can be combined. One has an exponent of 4, the other an exponent of 2. 4 plus 2 is 6 when I put those together. And the b to the 5th doesn't have anything to combine with, so he just gets to ride along to the answer. And last, we have y squared times y to the negative fourth. 3 versions of y here, so I need to add all their exponents. You need to remember that a variable with no exponent has a secret exponent of 1. So add these. Exponents of 2 and 1 and negative 4. 2 and 1 are 3. 3 and negative 4 is negative 1. Now here's where we have a problem. You're not allowed to give me y to the negative 1 as an answer. So this is where we got to think back 2 sections. In order to make that negative 1 a positive 1, we move that whole term into the denominator of a fraction. It'll become 1 over y. Yes, it's y to the first. Writing down that exponent is kind of pointless, so I'm not going to do it. However, if you choose to, that's entirely up to you. I won't mark it wrong if you do. Power to a power. So if we have something in parentheses, to a power, and then the parentheses to a power, we can simplify that by multiplying the exponents. So if I have 7 to the 4th, whole thing to the 3rd, that's saying I have 7 to the 12th, 4 times 3. Now, I will point out here that the direction does not say leave an exponential form. However, I'm going to leave it as 7 to the 12th because 7 to the 12th is very large. It's something in the neighborhood of 13 billion. I think we're good just writing 7 to the 12th. The next problem says 3 to the 6th to the 0 power. And you're done. If you're not done, listen to me one more time. 3 to the 6th to the 0 power. Anything to the 0 power is 1. If it'll help you, you can do the multiplication property. 6 times 0 is 0. But you absolutely must write 1 as your final answer for this kind of a problem. If you give me 3 to the 0, I am going to mark it wrong. Last guy here, I have x to the 2nd to the negative 4th times x to the 5th. I have both rules that we've seen so far here. So first, you want to take care of this x to the 2nd to the negative 4th. I need to have that as a single exponent. So 2 times negative 4 is negative 8. Once I have each version of x to a single exponent, I can go ahead and combine those by adding the exponents. Negative 8 plus 5 is negative 3. And of course, you cannot give me a negative answer. Rather, you can't give me a negative exponent in an answer. So we move that to the denominator. 1 over x to the 3rd is the correct answer there. And the last rule we have is power of a product, which looks like 2 bases in parentheses multiplied together, 1 exponent outside. What this is showing us is that with addition, or with not addition or subtraction, with multiplication in the parentheses, we can distribute an exponent. Give it to both or possibly all the things in the parentheses. So, negative 3x whole thing squared is negative 3 squared x squared. And yes, that negative 3 needs to be in parentheses. Negative 3 times negative 3 here is 9, and the x squared is x squared. Yes, this one you have to take this far. It says simplify, and 3 squared is not asking you to do too much, I don't think. The next example moves the negative sign outside the parentheses, which just means it exists. It doesn't go away ever. I still give the 2 to both 3 and x. 3 squared is still 9. It's just that because the negative sign was moved outside of the parentheses, It exists. It doesn't go anywhere. And last, we have x to the negative second times y to the 0 power. So start by giving the 3 to both the things in parentheses. This is an example of power to a power with the product rule. So when I give that 3 to the x to the negative second, it becomes x to the negative sixth. Negative 2 times 3 is 6. Negative 6. And when I give it to the y to the 0, y is going to be still to the 0, because 0 times 3 is 0. And we know anything to the 0 power is 1. We can basically get rid of it. That leaves me with x to the negative 6, which you're not allowed to leave me with. So we move that to the denominator of fraction. 1 over x to the 6th is our final answer. You are kidding me.